Okay, I trust that you tried it in your group. The first thing you have to do is you should know what octane is, and you ought to be able to write down a balanced chemical equation. So the formula for octane is C8H18, burns in oxygen to give carbon dioxide plus water. That's your combustion reaction here. You need to balance it. There's 8 carbons, there's 18 hydrogens, so I put a 9 out front of that. And now I'm left with a total of 25 oxygens on this side, which is an odd number, so I'll use my little trick, 25 halves, multiply both sides by 2, and then the balanced chemical reaction is going to be 2 octane plus 25 oxygen gives 16 carbon dioxide plus 18 water. Okay, that's the balanced chemical reaction that you should have come up with. Next, you want to see what's given. What's given is 1 gallon of octane, C8H18, that happens to have a density of 0.692 grams per milliliter, and also 3 kilograms of oxygen. And what's wanted is how much carbon dioxide is formed in this case when you burn a gallon of gas basically in your car. Now the problem here is we are limited by the amount of oxygen. We don't know if this is enough oxygen to burn all of that octane or not. So we have to figure that out first before we decide how much carbon dioxide has been formed. And so we will do our mole-mole ratio and figure out the ratio of moles of oxygen to butane that are given in this particular case. And what's needed here, of course, is 25, the needed from the balanced equation, 25 moles of oxygen per 2 moles of octane. To react all of it away completely, we would need, let's see, about 14.5. Is that right? 12.5 ratio. Okay? A 12.5 molar ratio of oxygen to octane. All right, so we just need to figure out the number of moles of octane and the number of moles, this is kilograms, excuse me, of oxygen given. All right, so first of all, for the octane, they didn't tell us a mass. They gave us the volume in a gallon, and then they also gave us the density in units of grams per milliliter. So what did you all do? All right, were you stuck there? What you needed to recognize is that you need to figure out the number of moles of octane, and so if you're given gallons, you got to figure out how can you get from gallons to moles. Well, you have a conversion factor between volume and mass, and once you get to mass in grams, you can always get to moles. All right, so you just have to get from volume to mass, and so you need to get from gallons to milliliters, and then once you get to milliliters using the density, you can get to grams, and once you get to grams, you can get to moles using the molar mass. Okay, so there's a little bit of a process to get to moles of octane in this case. And I looked up the conversion factor for gallons to milliliters, and as it turns out, there are 3,785 milliliters in 1 gallon. So that's your conversion factor there. And then the milliliters to grams, you can just use density, can be used as a conversion factor, because what it means is every 1 milliliter of octane weighs 0.692 grams. So every time you have a milliliter of octane, that's how much it's going to weigh. And so to convert from milliliters to grams, then you just say 0.692 grams per milliliter. That's your conversion factor, the density. And then to get from grams to moles, of course, you just use the molar mass of octane, which if you look up on the periodic table, carbon's 12, hydrogen's 1. 8 times 12 plus 18 is equal to, let's see, what is the molar mass? 114 grams per mole. Okay. Maybe given all of that, if you got stuck there, you ought to be able to stop the tape again and figure out the number of moles here. Okay. But I will work it out for you. It is one gallon, let's see, 1 gallon of octane. Let me see, I'm going to work it out right here. 1 gallon of octane, C8H18, converting to milliliters, 3,785 milliliters per 1 gallon. Converting to grams, it's 0.692 grams per 1 milliliter. Converting to moles, I put the 114 grams on the bottom per 1 mole of octane on top. And I end up here with about 18 moles of octane in 1 gallon of octane. Okay? All right. Now I need to calculate the number of moles whoops. That's weird. Lost electricity there for a second. Okay, next we need to calculate the number of moles of oxygen. In this case, let's see here. We're frozen. All right, the number of moles of oxygen. If we're starting with kilograms of oxygen, we just need to get to grams of oxygen, and then we can get to moles of oxygen. So in this case, 3 kilograms, there's 1,000 grams in 1 kilogram, and then the molar mass is 32 grams per 1 mole. And the number of moles of oxygen here is, let's see, 93 moles of oxygen, given that mass of oxygen. So the ratio then of oxygen to octane in this case is 93 moles of oxygen per 18 moles of octane. And that's going to give you a molar ratio of 5.2. But we said that the needed amount from the previous page was a 12.5 moles of oxygen to 1 mole of octane. This is only 5.2, so again, oxygen is going to be our limiting reagent. Okay, and once you know that, you ought to be able to calculate the mass of carbon dioxide formed. You would just start with your oxygen as your limiting reagent and convert to grams of carbon dioxide. So we'll just start with 3,000 grams of oxygen and convert moles of oxygen, 32 grams of oxygen, like we have been doing. And then now we're in moles of oxygen, we want to go to moles of carbon dioxide. And from the balanced chemical equation, 16 moles of carbon dioxide for every 25 moles of oxygen consumed in that particular problem. And then back to grams of carbon dioxide, 42 grams carbon dioxide per 1 mole of carbon dioxide. The units cancel, we're left in units of grams of carbon dioxide. And in this case, when you burn 1 gallon of octane with only 3 kilograms of oxygen, you're limited to forming what's 2,640 grams, 2,640 grams of oxygen, excuse me, of carbon dioxide, limited by the amount of oxygen you have available there. All right.